Okay, back to do chapter 3 stuff. So for number 10, you're asked to write a system of linear inequalities and a system of absolute value inequalities for the graph below. So if we start with part A, remember linear equations look like this. If I label this as 1, 2, 3, 4, for the first line, we know the slope is 4, and the y-intercept is also 4. And you can tell the slope is 4 because you have to rise up 4 and move right 1. And the shading's below, and we can assume that the line's solid if we don't see anything dashed. So it's less than or equal to 4x plus 4. For 2, slope is negative 4, still same y-intercept, and still shading's below. So less than or equal to negative 4x plus 4. For 3, back to positive slope, but now a negative y-intercept, and plus shading's above. And lastly, for the fourth line, slope is negative 4, y-intercept is negative 4, and its shading's below. Sorry, above, so it's greater than negative 4x minus 4. So these are our system of linear inequalities that describes the graph. For part B, okay, I kind of left myself short in space here. But remember, absolute value looks like this. And so if I were to draw this in green, you have an absolute value like this, and another absolute value like that. So let me label this as 1, and label this one as 2. So for the first absolute value, because it's going down with a vertex of 0, 4, the shading has to be below. A is going to be negative 4 because it's kind of like slope. It's going down negative, and you go down 4 over 1. And x minus 0, which will rise x, plus 4. And then for 2, shading's above, so you go greater than. Slope in x is positive a, and you got to say 4 because of 4 over 1. Still 0 for the x coordinate of the vertex, but the y coordinate of the vertex is negative 4. So that's the number 10 done. 11. In order to multiply two matrices, the columns of the first matrix has to equal the rows of the second matrix, or the inside dimensions have to equal each other. This is a 3 by 2, and that's a 2 by 3. So they match up. So the way the multiplication works will be the following. Now let me switch to a fine pen or ballpoint pen, that might help. We'll multiply this with this. So first row of first matrix times first column of second matrix. So we do 1 times 2 plus 0 times 2. Then repeat the process. First row of the second column, 1 times negative 1 plus 0 times 4, and repeat one more time. 1 times 3 plus 0 times 0. And then we repeat the process for the second and third rows. Second row, first column, second row, second column, second row, third column. Third row, first column, third row, second column, third row with third column. So 9 times 2 plus negative 3 times 2. 9 times negative 1 plus negative 3 times 4. 4 times 3 plus negative 6 times 0. Again, 4 times 2 plus negative 6 times 2. 4 times negative 1 plus negative 6 times 4. And 4 times 3 plus negative 6 times 0. And I did make one mistake. That should be a 9 right there. My apologies. Uh, so just taking kind of a quick glance at this, yeah, I think everything has been set up the right way. Oh, let's use 0, -3 also. And make sure everything else looks okay here. Yep, okay. So if we work that out, I'll switch that felt pen. Should get 2, -1, 3, 12, -21, 27, -4, -28, and 12. Then over here, so you want to do 2C, so you distribute. So if I distribute, I should get 8, -12, 20, 6, 12, 0, 18, -8, and 10, plus, and we ran out of Dias, that'll be 2, -1, -3, 0, 6, -5, -2, 0, 1. Add them up. -10, -13, 17, 6, 18, -5, 16, -8, 11. And then finish it up, we should get -8, 12, -14, 6, -39, 32, -20, -20, and 1. Okay. 12. So I went over this with you guys in class, linear programming, but I figured just do it again, it might help. First step, assign your variables. So x will equal number of jars of tomato sauce. Y will equal number of jars of salsa. And by the way, I will tell you what x and y will equal for this problem on the final exam. You will see this problem on the final. Just so that your graph is not weird, I'll tell you what to make x and y, so you don't have to worry about that. Second step, objective function. So we want to make money, so we use P for profit. $3 for each jar of tomato sauce, $1 for each jar of salsa. Third step, constraints. Obviously, we can't have negative jars of salsa or negative jars of tomato sauce. So x is greater than or equal to 0, y is greater than or equal to 0. We also need 10x plus 5y to be under 180. That's a tomato constraint. The onion constraint is this, x plus 1/4 y has to be less than or equal to 15. Fourth step, graph. I will provide you with a graph with the proper units labeled, so you don't have to worry about making a graph. But we do know it has to be in the first quadrant. It helps to find the x and y intercepts for your constraints. So if you're here, x-intercept was 18, y-intercept was 36. Here, x-intercept 15, y-intercept 60. So 6 would be roughly there, 36 would be roughly here. We'll say that's 15. We'll say that's 18. Change up colors again. Let's go light blue. So you have that one. You have that one. Ooh, that's really good. I was pretty accurate there. Shading. We'll use the yellow highlighter. It's kind of fun to use yellow. Set your shaded region. Okay, back to green again. And these are your corners. So the fifth step is identify what the corners are. Okay, we're back to light blue, whatever. There we go. 0, 0, 15, 0, 0, 36. And to find the point of intersection, use the Solve2Q program in your calculator. If somehow your programs are wiped away right before the final, don't worry, I'll give it to you on the day of the final. Not a big deal. Excuse me. You should get 12, 12. Let me find the point of intersection for those two blue lines there. And then the sixth step is a plug into the objective function. So 0, 0 gives you a profit of 0. 15, 0 gives you a profit of 45 bucks. 0, 36 gives you a profit of 36. And 12, 12 will give you a profit of $48. And so that's the answer. Sell 12 jars of each to make 48 bucks. 13. And then I'll stop the video again. Graph these first. And then find the points of intersection. And the good thing is I already put these in slope-intercept form. So let's use a ballpoint pen. -2. And you want to go down 1 over 4. Connect those two. Okay, I'm a little bit off there. -2 again for the next line. Up 1 over 1. And then 3. Down 3 over 2. Shade. Because you want to go above the first line I drew, below the second line I drew, and below the third line I drew. So that's the enclosure. The points of intersection can be found by using the calculator. You could just plot each line and then find the points of intersection, which you guys should know how to do. That's using second trace intersect. Yeah, if you're having trouble with that feature, just ask me on the weekend or in the review. But the points of intersection are, I think, pretty obvious here. 2, 0, 4, -3, and 0, -2. And then you're asked to find the area. I will give you this formula. It's plus or minus half the determinant of x1, x2, x3, y1, y2, y3. Those represent your points of intersection, by the way. 1, 1, 1. So those are the points of intersection. Those x and y values. So, and what order you put them in doesn't really matter. It won't matter at all. So let's say do 2, 0, 0, -2, 4, -3, 1, 1, 1. Work it out, you should get 5. And remember to use the second x -1, that's the matrix menu. Be able to type in your matrix. And you want to take the determinant which is the math submenu of the matrix menu. Okay, so that concludes the chapter 3 problems.